This lecture is going to go over predicting products of reactions. Three things you want to have out. Periodic table, you'll want to have out your types of reaction sheet that we did in the last lecture. And also you have another chart in your packet that says solubility rules. So it's a chart, it has a few columns on there. You'll want to have that as well. So we'll take a look at that solubility rules chart first. So what it means is that if something is soluble, so if that chart says it is soluble, that means that it's going to be aqueous. So it can dissolve in water. If something is not soluble, so it says it's insoluble, so we'll write that down as well, insoluble. That means it will not dissolve in water, meaning that it will be a solid. So if it is soluble, it dissolves, it's aqueous. If it's insoluble or not soluble, it will not dissolve, meaning you're going to be left with a solid. So if you're looking at that, you'll see things like all nitrates are soluble, or maybe you see all chlorides, bromides, and iodides, so all of your halogens are soluble except, so some of these will give you exceptions where it says everything is soluble except for the ones of silver or of copper 1, so you just kind of have to be aware of that. Now, you do not have to memorize this. You will be given a list of solubility rules when you take your quiz and when you take your test. So the key is that you're able to read it, not that you can memorize it. So let's do a few practice ones here. So looking at the first one, we have calcium hydroxide. So if you find in the column where it says hydroxides, it should say all hydroxides are insoluble except, so all hydroxides are solids except for those of sodium, potassium, and barium and calcium. Those are soluble. So calcium is one of those, so this is going to be soluble. So we would say that this would be aqueous. All right, now looking at magnesium sulfate. So looking for the sulfate column. So all sulfates are going to be soluble except for those barium, lead-2, calcium, and strontium. So magnesium is not one of those, meaning that it is soluble. So this is also going to be aqueous. Aluminum hydroxide, so another hydroxide. So all hydroxides, we're thinking they're solid, except aluminum is not one of the exceptions, meaning that this is insoluble, so this is going to be a solid. Lithium nitrate, find nitrates on your sheet. All nitrates are soluble, so that means this is going to be aqueous. I want you to try the last two on your own. Pause it, check through your chart, come back, and take a look at the answers. All right, so calcium carbonate and silver iodide both are insoluble, so both of those will be solids. So your silver, your iodides are soluble except, so silver is one of your exceptions here for making it insoluble. All right, so actually predicting products. You're going to have to use these solubility rules because you're going to have to know what the state is of any of the products that you predict. So what we're going to do is we're going to be given the reactants in an equation. So when looking at the reactants, you can identify the type of reaction that will occur. So we have to use these reactants in order to predict the products, because if you remember, what we have on the reactant side, we have to end up with on the product side. So we're going to be using those same things, except we're just going to be rearranging them a little bit. So you have to remember to use all of your naming rules as you are forming products. So just because something has a subscript 2 on your reactant side doesn't mean it's going to have a subscript 2 on your product side, because that subscript 2 may be to balance out a charge. You have to rebalance your charges on your product side. Also have to remember those Hofbrickel's. And then you're going to balance the equation. Now, today, we are not going to balance the equations. That's just going to make the video even longer. You've already done that. But if you want to go back after the video is over and balance all of the equations, that's fine. But just know that you are going to be asked to do that on your quiz. All right, so our first equation here, calcium hydroxide, which is aqueous, plus phosphoric acid, which is aqueous, gives us something and something. So the first thing we have to do is predict the type of reaction that's going to occur. Now, when we look at this, the first thing you want to look for is how many reactants do I have? I have 2 reactants. Now, are they special, like a carbon compound with an oxygen? Because then I know it's a combustion. Do both of them have 2 parts? So the calcium and the hydroxide, and then the H and the PO4. Do some of them have 1 part? Do some of them have 2 parts? These are the questions you're going to want to start asking yourself. So what we see here is we have a 2-part with the calcium hydroxide and a 2-part with the phosphoric acid. So we have a positive and a negative and a positive and a negative. Now what does that look like? That looks like a double displacement reaction. Okay, so what's going to happen? My positives and my negatives are both going to flip. So what I'm going to have here is my calcium is going to pair up with my phosphate here, and my hydrogen is going to pair up with my OH. So calcium phosphate would be Ca3PO4 2. And then if I put H with an OH, I'm going to get water. Oh. Now we have to determine our solubility. So using our solubility rules, phosphates are insoluble except for the exceptions listed there. Calcium is not one of those exceptions. So this is going to be a solid. And then water we know is a liquid. And then after that you're going to balance. We're not going to do that here, but you can come back and balance that equation. So first thing we did is we looked to see what do we have on this side and this side. What are they made up of? So we're going to do a few more examples here. This is something that just takes practice and practice of you identifying. That's why it's important for you to be able to identify the types of reactions first. All right, C4H10 plus O2. How many reactants do I have? I have 2 reactants. I have the butane here, and then I have the oxygen gas. So this one should be letting off a red flag here. This looks like something special because I have a carbon here, a carbon molecule plus oxygen gas, which means that this is a combustion reaction. Now, what do all combustion reactants give us? They give us CO2 plus water. Now, we know that carbon dioxide, we know that is a gas, and we know that water is a liquid. You can go back through and balance this if you want to. But anytime you see this right here, something plus oxygen gas, and if it's with a carbon molecule like this, you know that it's going to be a combustion reaction. That oxygen should kind of hint you towards that. All right. Aluminum plus bromine. How many reactants do I have? I have 2. 1, 2. Is there anything that can switch places here? No. The aluminum is by itself. The bromine is by itself. So the only thing that can happen right now, since there's no things to switch places, is they are going to come together. So what's that going to give me? You got to balance out your charges here. AlBr3. And then looking at our solubility rules, this is going to be aqueous. Then we would go through and balance this equation. Because all bromides are soluble except for silver, lead 1, and mercury 2. Alright, taking a look at this one. How many reactants do I have? I have 2. Are there any things that can switch places? This is a plus, H is a plus, this is a minus. So my pluses can switch places. If I'm only having one thing switch places, then I have a single displacement reaction. That last one was synthesis too. We'll go back to that after this. Single displacement. So if I have one thing that's displacing, it means that this guy and this guy are going to switch. So I'm going to be left with H2, remember that's a Hofbrickel, plus Mg. Magnesium has a +2 charge. Nitrate has a -1. So we need a 2 there. Now looking at your solubilities, this is going to be a gas. And then this one is aqueous. So you might be looking at this thinking like, how do we know this is a gas? We don't see that on solubility. Know what your gases are. Most of your Hofbrickels are gases on their own. Okay, so if you have that Hofbrickel on its own, you're looking at a gas. Things like carbon dioxide, you should just know that that's a gas anyway. That's kind of just some prerequisite knowledge you should have from biology. But then something like magnesium that's a solid. Well, think about where magnesium is on the periodic table. It's in the earth metals. So earth metals are metals, and a metal is a solid. Okay, so you're not going to have a chart that has some of these on there, but just use your knowledge of things you've already learned this year and apply that to those situations. Anything in your transition metals, if it's by itself, it's a solid. All right, AgNO3 plus potassium phosphate. So potassium phosphate is one of those exceptions that is going to give you an aqueous phosphate here. So we have 2 products, silver nitrate and the potassium phosphate. Let's look at our parts of both. That's a positive, that's a negative, that's a positive, that's a negative. What's this look like? A double displacement. These are going to switch. These are going to switch. So double. All right, so my silver is now going to pair up with my phosphate to give me Ag3, because silver is a +1, PO4, plus the potassium now goes with my nitrate, KNO3. All right, now determine our solubility. Silver phosphate is not one of those exceptions for your phosphates, so that is going to be a solid. And then all nitrates are soluble. And then we can go back through and balance. All right, looking at this one, how many reactants do I have? I only have 1. So nothing can switch places. Nothing can combine. So the only option we have here is for this to break apart, which is decomposition. So this is going to decompose. It's going to decompose into its two parts. My first part is the silver, my second part is the oxygen. Now, remember, the only reason that that 2 is there on that silver is because it's balancing out the charge on the oxygen. So I'm going to be left with silver plus oxygen. But what does this oxygen need? It's a Hofbrickel. Silver is a transition metal, so that is going to be a solid. Oxygen is a gas. Right? Let's slide back. There's one of these we didn't identify. This one right here. So this was a synthesis reaction because we are making everything come together. Right? So there are plenty of practice problems on these. So please do them all. Do not say, oh, I've done 3, I know what I'm doing. Because there's a lot of different situations that you're going to see in those practice problems that you're not going to see just by doing 1 or 2 of them. All right? So first, identify your type of reaction. Then you're going to predict those products, remembering to use those naming properties over again. Make sure your charges balance out. Determine your solubility. Use that solubility chart. You will be able to use that. And then you are going to balance out the equation, which we did not do today. All right, so take a look at these. Let me know if you have any problems. Good luck.